Hello and welcome to the YouTube channel that so far has only aspired to make one video. Today we are going to be talking about SIP resistors, and you'll get a basic overview as well as an in-depth explanation on how to test them as well as their application in designing electronics. So let's get right into it. SIP resistors, or serial inline package resistors, are also known as resistor arrays or resistor networks. SIP resistors can come in a lot of shapes, however I found that one of the most common looks like this. As you can see, there's sort of a boxy shape to it. It almost looks like an IC component, and then we've got another one that looks like this here. This one almost has like a capacitor coating on the outside. So those are the two main types you'll see there. The best way to think of how these work is if you imagine multiple resistors all in a line with one lead of the resistor connected to a ground source and the other leads connected to their proper components. So as you can see here in this quick diagram I drew, this would be sort of the inside view of an SIP resistor. You have one ground lead, which is normally indicated by either a circle or a square, and that is connected through multiple other leads here, with resistance values going through them. Testing SIP resistors is a fairly easy process. One of the first things you may notice about an SIP resistor is the markings on the side. So, as you can see here, this is a very large scale model of SIP resistor I recently 3D printed. You'll notice that it's marked by a square here, which indicates pin 1, or the ground wire, and it's followed by some text. Now this is just some text that I put on there to sort of show what it might look like on a SIP resistor. And then, of course, we've got the multiple leads here. Most SIP resistors, as previously stated, will have either a dot or a square, followed by a series of numbers and letters. The dot or square marks pin 1 of the resistor. Pin 1 is the pin that connects to all the other pins. The resistor is commonly identified by numbers and letters after this marking. The best way to identify the values of the resistor, unfortunately, is to look up these numbers and letters. SIP resistors have a variety of ways to identify their values, and in some cases, the code they use are specific to the manufacturer. There are many ways to test an SIP resistor, however the most efficient way is as follows. Using a multimeter in the resistance or ohms setting, connect one of the leads to pin 1. Now, being that this is a model, this isn't actually going to show anything, but basically this is what it would look like. So, as you can see, we've got it on resistance there. And we are going to take one lead and connect it to pin 1. And now we're going to take another lead and connect it to another pin here. Now, if this were an actual SIP resistor, we should be getting a reading here on the multimeter. However, because this is made out of plastic, that is not going to be the case here. In most cases, SIP resistors will have the same resistance from pin 1 to the other pins. However, there are less likely cases where the resistance value changes depending on the pin. This is why it may be necessary to look up the specifications for the SIP resistor using the code on the side of the component, which would normally be located here. Something I had issues with initially when trying to find these components to learn more about them is I was not using the proper keywords. If you would like to research these components yourself, I recommend looking up SIP resistors specifically, as this normally generates the most results. If you would like to research these components yourself, I recommend looking up SIP resistors specifically, rather than using the other terminology for them. This normally generates the most search results. Another issue I've found while dealing with SIP resistors is looking up the values and type. As previously stated, not all manufacturers use the same type of code system for them, which can make it difficult to actually diagnose and figure out what the values should be showing on the multimeter. This being said, SIP resistors as a whole are very useful components. They allow board manufacturers to install several resistors onto a circuit board that might otherwise take up a lot of space. The most common example of an application for these resistors is in a DIP switch, or dip switch, which utilizes multiple switches in a row. Something to think about if you have time to test an SIP resistor is the fact that the resistors are parallel, and as such, when you test them, you will find that connecting both leads of a multimeter to two different pins, where neither one is pin 1, you will find in a conventional SIP resistor that the resistance is double the resistance. This is because, as you can see in the diagram here, let's say we were to take this resistor, this SIP resistor, as an example, and we place one lead of the multimeter on this pin here, and the other lead on this pin here. That would give us double the resistance rating, because technically we would be moving current through two resistors of the same value. I hope this helped someone out there who was struggling to find out more about these components. I was having issues with them myself because I had never seen them before when I initially started working on these. So if you have any questions about this video, feel free to comment. Considering this channel has only one video on it right now, and the video is about an uncommon component that most people don't know how to even begin looking for, I doubt your question will be lost in the masses. Thanks for watching, and happy learning!